Okay, so the easiest multiplication is the two matrices we talked about yesterday, the two special ones. A row matrix and a column matrix. Okay, so notice, they created a row matrix of quantities. Okay, Reuben went in and he bought himself 4 bags of chips, 5 candy bars, 1 pack of crackers, 3 sour drops, and 2 bags of cookies. Okay. Each bag of chips, they created a column matrix of the prices. Okay, so each bag of chips was 30 cents. Each candy bar was 35 cents. I really wish these prices were still in play. 50 cents for a pack of crackers, 20 cents for some drops, and 75 cents for some cookies. Okay, so we want to find the total amount that Reuben paid for his snacks. Well, how would you do this? If he bought 4 bags of chips and they were each 30 cents, 4 times 0.30. Each candy bar was 35 cents. Well, we bought 5 candy bars at 35 cents. We bought 1 pack of crackers, and those were 50 cents. We bought 3 sour drops, and those were each 20 cents. And we bought 2 things of cookies, 75 cents.
You know what I'm saying?
Okay, so you said I had to multiply how many of each thing I bought times the price of it. Then what do I do? Add it all together. Plus, 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 plus.
Because you know our white soccer shirt?
Mm-hmm.
I wore it going to get some Mexican food. I'm gonna drop some Mexican oil right there, and it will. So now I'm sad I can't wear it.
$5.55.
Oh, the t-shirt.
Yeah, the white.
I thought you meant our jersey. I was like,
No,
I'm gonna kill you.
the white t-shirts that we got.
That sucks.
I know. I'm sad now.
You said $5.55. Reuben spent $5.55.
That's how much about it? Yeah, $5.55.
That's how much I got to pay for.
Okay, so yesterday when we talked about adding and subtracting, we said that they had to have the same dimensions. Well, take a look at these dimensions. My row matrix is a what by what? 1 by 5. I've got 1 row and 5 columns. My column matrix is a 5 by 1. Take a look at my answer. What size is that matrix? A 1 by 1. Can anybody figure out what the rule is for multiplying and the dimensions?
There's 1.
They cancel each other out.
Okay, they kind of cancel each other out. Okay, in order to be able to multiply, the columns of your first matrix have to match the rows of your second matrix. 5 and 5. My answer then is my row and my column of the dimensions. So the inside numbers have to match. The outside numbers are what my answer looks like. So in other words, if I gave you something like, I want to multiply a 1 by 2 and a 2 by 7, can I do that?
No.
Yes, because
No.
the inside numbers are together.
Oh,
Yes. I can do that. 2 matches 2.
And then the 7.
My answer is a 1 by 7 when I'm finished.
So it's only the inside that has to match.
Only the inside. So it's very important that you pay attention to the order because, for instance, sometimes they'll tell you D is a 2 by 3 and E is a
They'll word it like
3 by 1. And they'll put, I want to multiply E times D. Well, if I put E first, that means my 3 by 1 goes first and D comes second, so my 2 by 3 goes second. Well, it should be a 3. My bad. My 2 by 3 would go second, so this one can't be multiplied because it's a 1 and a 2. But if I switched it and did D times E, I could do that, and my answer would be a 2 by 1. Okay, so there's a big difference if I put it in this order or if I put it in this order. Because this can be done, this one cannot. Okay, so you've got to pay attention to what order they want you to multiply it in. Okay. All right, so let's set up some matrices. On the next page. Practice 1. So suppose Ruben's friend Terry goes along with him to the store. Terry buys a bag of chips for 25 cents, 2 candy bars at 45 cents each, 2 packs of gum at 30 cents each, and a medium drink for 75 cents. Okay. Quantity matrix. Let's make that the row. So, how many items is Terry buying?
4.
Okay, we start with how many chips?
1.
1,
Then 2.
then 2,
Then 2.
then 2,
Then the medium, which is
1.
just 1 drink. Okay. So, there's your quantity matrix. Remember, whatever order you put this in, when you do the price matrix, the price that corresponds to each quantity has to go in the same order. So we put chips first. So when I go and do my column, I need to put the price of chips first. 25 cents.
45.
You said 45 cents for the candy bars,
Then 30.
30 cents for the packs of gum,
And 75.
and 75 cents for the drink. So we need to multiply. We multiply 1 times 25. Well, that's 25 cents. We multiply 2 times 45. 90 cents. We multiply 2 times 30 cents. And we multiply 1 times 75 cents. Add them all up, and that gives me a grand total. So 5 and 5 gives you 0. Carry the 1. 10, 18.
2.5.
I was close.
So Terry only spent $2.50.
Miss Smith.
What's nice to have that in real life.
So close.
So close, but no cigar.
I said 240. I said 245. So close.
Okay. So it's pretty easy to multiply if I just have a row and a column. Okay. It gets more complicated as I extend my rows and my columns. That's why we have calculators. I am not going to force you to do it by hand. If I actually had to teach an entire unit on matrices, oh, honey, you'd be doing it all by hand. And I'm pretty sure my only test would be like 30 by 30 matrix.
Oh, that doesn't.
And make you do it all by hand.
If that was the only test,
Only one question?
maybe. I'll skip it a bit.
Okay.
Shit, the bonus round be a 50 by 50.
Okay, Mr. Duncan has invested some money. He put $10,000 into a 12-month CD at 7.3% annual yield. $17,000 into a credit union at 6.5%, and $12,000 in bonds at 7.5%. What will be his investments after 1 year? So it says, write a row matrix that shows the current value of each investment. So I want my money as a row. What does that look like? How much money is he putting in? 10,000 into the first one. 17,000 into the second one. And 12,000 into the last one. Okay? Write a column matrix that shows the yield of each investment. So $10,000 was at 7.3%. What's that look like? What am I actually multiplying by? Please think back to last chapter.
100 plus.
Wait, I heard somebody say 0.073. Annual yield. I agree that there must be a 0.073. What is she missing? The 1. Remember, it's annual yield. You're trying to gain money. So it's got to be over 100. Okay? If I would have just multiplied by 0.073, I would have lost money. You would have taken money away. Okay? So just be careful. When you're gaining money, that 1's got to be out front. So what does 6.5% look like then? 1.065. And finally, 7.5. Beautiful. Okay? So, same idea. I need to multiply 10,000 times its yield. 10,730. I need to multiply 17,000 by its yield.
18.
And I need to multiply 12,000 by its yield.
12,900.
Add them all up to get our grand total. $41,735 is how much he has at the end of the year. If I switched it up and I said, how much did he make in a year? We'd have to subtract what he originally invested to see how much it actually increased. Okay. So just be very careful on what it asks for. Right, multi-dimensional. Here we go. It's getting bigger, 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 bigger. Woo, 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 woo.
You lost me already.
This ain't gonna work. All right, so let's talk about this before we actually do it. I'm actually going to show you how to plug this one into the calculator. So they want us to multiply. We're ordering 5 pizzas and 3 salads. And we can order from 3 different restaurants. We can order from Vinny's, Tony's, or Sal's.
Vinny sounds good.
Okay.
Sal's not about good.
So what size is this matrix, the 5, 3?
Oh, 1 by 2.
1 by 2. This is a 1 by 2. What's the second matrix?
2 by 3.
2 by 3. So, can I multiply them?
Yes.
Yes. This
Yeah.
and this match, so we're good.
Your answer will be 1 by 3.
My answer should come out to be a 1 by 3. My answer should be a 1 by 3 matrix. So, basically what your calculator is going to do for you once I show you how to plug this in, this row has to multiply by this column and get your first number. It then multiplies by this column to get your second number, and it multiplies by this column to get your third number. That's where your 1 by 3 comes into play. So you can do this by hand. It is possible. You take 5 times the 1125, 3 times 369, get those two answers, add them up. That's your first answer. Okay. It's just a longer process because you have to do it multiple times. So everybody get their calculators. Because come test day, I'm not helping you with this.
Wow.
So make sure you know how to do this. 1, your final exam, I can't. 1, your final exam, I cannot. 1, I won't even be in this room. Okay, I'm not allowed to give my own test. Okay. You cannot ask for help on how to use your calculator during your exam. We have got to practice this. Really? How do I turn it on? Okay, you have a matrix screen. And the matrix screen is right beside your sign button. Okay, you want to hit second. And then the X raised to the -1 button. That'll take you to this screen. This is where you find everything you need to do with a matrix. Okay, so you're going to hit second, and then you're going to hit this button right here beside sign, and that'll take you to your matrix screen. Okay, so we've got 2 things that you need to know. This screen right here is where you use the matrices. You have not put any data in yet. So this is where the data is stored once you put it in, and this is how you use it. The screen we need to be concerned about right now is the edit screen. I want you to go to edit. I want you to then choose choice 1, matrix A. Okay, you told me my first matrix at 5, 3 is a 1 by 2. So the first thing you have to tell your calculator is I have a 1 by 2 matrix. So you want to hit 1, enter, 2, enter. Okay, so all you did right now is tell your calculator the dimensions of your matrix. I should have 1 row, 2 columns.
Right here.
What's up? So scroll over to edit. And now choose 1. And you need 1 enter. And 2.
So what I'm hearing is after.
That's all we've done so far. You had to tell your calculator how big is my matrix. Okay. Once you tell your calculator how big your matrix is, we then need to input the values. So the first value of my matrix is a 5. So you want to hit 5, enter, and 3, enter. You've now just put in your first matrix. It's a 1 by 2, and the values that are inside of it are a 5 and a 3. Questions? We good? Okay. Go back to your original matrix screen. So second matrix. Notice that beside A now, it says 1 by 2. It stored the matrix you just put in. Okay, so there's your first matrix. We need to go back over to edit because we got to put in your second one. This time I want to go to matrix B. Okay, so hit number 2 or scroll down and hit enter. Matrix B was a 2 by 3. So you need to give it dimensions. 2 by 3. Notice how your matrix got bigger when you did that. It's showing you where you put your numbers. Okay, as you input numbers in the matrix, it's going to move from left to right. So you're going to have to put in the row and then the next row. It's not going to jump up and down. You go across and then across. So are we good with B and 2 by 3 right now? Okay, so we need to start inputting our numbers. Our first number in the first row is 1125. 11.25, enter. Notice it automatically jumps to the middle. That middle number is 11.96. Enter. 11.96. 2.90. Enter. 3.69. Enter. 4.34. Enter. 4.35. Enter. Anybody need help inputting this matrix?
No.
Okay, so now all we do is just quit out. So second mode. This takes you back to the regular screen where you can add numbers, multiply numbers, take the square root of numbers, all that happy stuff. Okay, so my 5x3 matrix was matrix A. So we need to go back to your matrix screen instead of going to edit, because I want to actually use my matrix now. I just stay under names. So I want matrix A. I want to use the numbers that I input for A. And I want to multiply that against matrix B. So I've got to go back to my matrix. And this time I want matrix B. Okay, so you out to the main screen. Put you out to this main screen. Now you need to go back to your matrix. I need to use matrix A. So instead of going to edit, you just want to use A. So hit 1 or hit enter. Okay, times. Go back to your matrix screen. And I want to multiply that by what I put in.
Oh, you're doing this already?
The bottom
There
of
it
the
is.
matrix, they also say
Okay. Does anybody else need help getting this up?
Oh, yeah.
Okay. When you hit enter, you get this.
You get the first row. What about the second?
You only get one.
My answer is 1 by 3.
Yeah.
Then why are you
mine
worried
gave me
about
two
the
rows?
zero?
Why did? Because mine gave me 2 rows.
That's what I'm saying. Like, yeah, you probably did press enter.
I did not. I pressed it once.
And then if you press enter, you would have got the same row again.
Stop. Chill.
I'm talking to her.
Chill.
You figure it out.
I will figure it out.
I would enter again. I would have went the same.
You made this first matrix a 2 by 2.
Oh.
Okay. So what we just did is you got an answer of 67.32, 72.82. If you use the right arrow, you can see the last price of 72.55. Well, we know that it should have been a 1 by 3. Well, I've got 1 row, 3 columns. You're good. Okay. Not only do you have to do this, though, you've got to tell me what in the world that means. Okay. What in the world does this mean? So if I asked you, once you got your answer, what is the interpretation of AT12?
72.80.
Total for Tony.
So 72.82. This points me to this number. And Sammy just said that's the total for Tony's. It's in the second column. So that's how much money I would spend at Tony's if I bought 5 pizzas and 3 salads. So this is the money for Tony's for 5 pizzas and 3 salads. Questions? Okay, let's look at these. Just like we did for adding and subtracting, but now I want you to tell me, can I multiply these? So again, Yes or no? If it's yes, what are the dimensions of my final answer? So, Q is a 1x4, P is a 4x2. Okay, Yesenia says yes. What's my answer then, Yesenia? Not a 1x4. 1x2. Okay, these match, they cancel out. Okay, you're fine. Okay, what about a 1x3 and a 2x3? No. 1x5, 5x4. Yes. And a 1x4. And what about a 1x2 and a 4x2?
No.
So adding and subtracting exactly the same, multiplying, the inside numbers have to be the same, your answer is the outside numbers. Okay. Okay. So we need to set up some matrices and we need to decide how we multiply these. Okay. So they give you your first matrix. Well, they give you one of the matrices. This is a matrix. Okay. What this shows is a credit union's investments in loans and bonds in Massachusetts, Nebraska, and California in thousands of dollars. So, Massachusetts, $230,000 in loans, $780,000 in bonds. Nebraska, $440,000 in loans, $860,000 in bonds. Okay, I need to figure out how am I going to make a matrix that can multiply against this. What is this matrix?
Point of interruption. Do you have Tanisha Kelly?
She's at an AP test this morning.
Okay, thank you.
Uh-huh. This is a 2x3 matrix. Okay, this is a 2x3. Okay, all they give us in the word problem is 6.5% and 7.2%. How am I going to make my other matrix so I can actually multiply? Okay, so was that Kimberly that just said that or you? Okay, so Kimberly automatically said, well, first it's being invested, so that's over 100. Okay. 1.065. Do I put that beside it or underneath it?
Underneath, they're two different things.
Understand that. But listen, if I put this here,
Then it would be the.
what is this matrix?
The 1x2.
2x1.
And then it
Can
would-
I multiply a 2x1 and a 2x3? No, it's got to be a 1x2. So that tells me that this number has to go here. Okay. So just be very cautious of that. Okay. So in other words, what creates the rows here has to be your columns here. Okay. So you would multiply this times that in your calculator. Instead of doing that right this second, I'm going to put your answers up here. So 1081.11,
Yes.
1390.52, and 1731.88. Okay, again, you multiplied a 1x2 and a 2x3. So my answer should have been a 1x3 matrix. 1 row, 3 columns. What is 1731.88? What does that mean? What is that?
Total number of loans and bonds that California.
the total earnings of loans and bonds for California. Okay, it's in that last column, and the last column is California. Good. Questions? Okay, we're going to skip the next one.
Ms. Smith, when you put this in the calculator, does it matter if you put it how they are here or put it how
Wait, does it matter if I put it how what?
it is here? You have to put it how
No, you can put it in there. Just know that your answer's in thousands. That's all. All right. So the same thing happens for a multi-dimension times a multi-dimension. It gets even more complicated to multiply by hand. Okay? Each row has to multiply by each column. So we take a 4 and 3, multiply it here, here, and here. That gives me my first row. We multiply this row, here, here, and here. That gives me my second row. We then multiply this one, here, here, and here. That gives me my third row. Okay, so this time I started with a 3 by 2, and I've got a 2 by 3. So my answer here should be a 3 by 3. Okay, my answer here should be a 3 by 3. I'm going to give you plenty of time to practice with the calculator. So I'm going to put this answer up to here in 1 second. Okay, and then you guys are going to practice the next page with the calculator. So your answer here is 5607, 5976, 6732, 6086, 6520, 7282, 6065, 65, and 7255. Okay. So if you would have plugged that into the calculator, this is what you would have done. So take a minute and get this copied, so then we can talk about what these mean. Because again, it's not necessarily, can I multiply these? Can I understand what it's telling me once I do? The first number that they would like me to interpret is BT, which means I've multiplied the two matrices. They want to know what the number 2, 3 means. So 2, 3 means I'm in the second row, third column. What does 65 represent? What is that telling me?
The total of 4 pizzas and 3 salads.
That's tell you how many
Sal's. The
salads
total
it is.
salads.
Okay, so this is Sal's restaurant for what?
Salad.
What am I buying?
Salad.
How many?
34.
Think about what row I'm in.
Yeah, 4.
4.
So 4 pizzas and 4 salads. This is Sal's price for 4 pizzas and 4 salads. Okay. You're in the second row. Well, if you look at that matrix, that's option 2, which was 4 and 4. 4 pizzas, 4 salads. We're in the last column, which was Sal's. So we know we're at Sal's restaurant. The second number they want us to interpret is BT 32. So now we're in the third row and the second column. What's 7282?
5 pizzas, 3 salads, Tony's.
Okay, so now we're at Tony's restaurant because we're in that second column. And we ordered 5 pizzas and 3 salads. Okay, so they might give you the 2 matrices that they multiply together. They may give you the answer for the multiplication. Then they might say, Well, if I'm in BT12, what is that? What am I looking at? Can you interpret what it's saying? Okay, the next page is all multiplication. Okay, I want you to spend some time practicing putting these into the calculator. Okay, every time. The first one, A, B, and C, you can literally plug in A, B, and C into your calculator and then just use those. Okay, clear it out afterwards. I want you to just spend the rest of the time here plugging these in. I can't give you homework on this because you need the calculator to multiply. I would be insane to make you do this by hand. Okay, again, if we taught matrices clear from the 7th grade, like we used to, I'd totally make you do this by hand. Okay, it's insane to go back and try to teach you all of this and by hand and all that happy stuff. So take some time, figure out how to plug it into the calculator. I have answers. So when you get a couple and you want to check yourself and make sure it's okay, come see me. I will gladly look at it. Tell you to go back and check some of these, some of the other ones. Okay. Questions? If you're feeling gumptious, try the word problems on the other page. Or is it on the back of that one? On the back of that one. If you're feeling ambitious, try some of those. Okay. It's a matter of setting it up like we did with that loans and bonds, creating the other matrix, figuring out what times what. How do I handle that?